Okay, so I am on page 11 of your class packet. And so you want your class packet out and you want your graphic organizer out because we're gonna fill in another box on there. So what we're gonna do today, this whole chapter is quadrilaterals, which are four-sided shapes. We've done kites, we've done trapezoids, and now we're gonna do parallelograms. So a parallelogram is a quadrilateral with two pairs of parallel sides. A trapezoid just had one pair of parallel sides. So a parallelogram, I mean, parallel is in its name. It has all parallel sides. So the top is parallel to the bottom and the sides are parallel to each other. That's what those arrows on the picture mean. And remember, parallel lines mean they're never going to intersect. So right here, this is kind of like a summary of what your graphic organizer is going to be. So we're not going to fill out that. We're going to fill out your graphic organizer instead. So right now, you want to fill in these properties for a parallelogram, and also I have a picture here kind of describing all these different properties. So maybe pause the video, take the time to write all this down, and then come back and hit play, and then I'm going to explain what all this means. Okay, so assuming that you pause the video and wrote all this down. First, it says all the properties of a trapezoid. Because it is a branch of a trapezoid, because trapezoids also have parallel lines, all these properties are true for parallelograms. Opposite sides are parallel, which we talked about. Top and bottom are parallel to each other. Sides are parallel to each other. Opposite angles are congruent. So this angle will be congruent to this angle, and this angle will be equal or congruent to this angle. So that was what it means by opposite angles. Opposite sides are congruent, so top and bottom are equal, sides are equal. If one angle is a right angle, then you can assume all four corners are a right angle. And the diagonals bisect each other. So remember what the word bisect means. Bisect means it cuts in half. So these diagonals that go through your parallelogram, each one is cut in half. So these would be both 5, for example, and these would be both 4, for example. So we're going to use those properties to go back to page 11 and answer those questions at the bottom. So for this first parallelogram, again, these arrows mean all the sides are parallel to each other. So that's why it's a parallelogram. So it says find the length of AB. Well, AB would be 10 centimeters because the opposite side is also 10. Remember, the sides are equal, top and bottom are equal. In question 2, it says find the measure of angle D. So this angle right here. Well, this would be the same as a trapezoid in the sense that if the angles are on the same side of the parallelogram, and they're both on the left-hand side, these two angles have to add up to 180, and I think that's a 110. So what you would do is do 180 minus 110, and you get 70. So the measure of angle D would be 70 degrees. Okay, so now for 3, 4, 5, 6, 7, 8, we're not going to do number 5, but I'm going to walk you through these using this parallelogram to the right. It says find the measure of ML. Well, again, ML would be 12 meters because they would be opposite sides are the same. What's the length of LP? Well, that would be 10 meters. We're not going to do number 5. Number 6, the length of LN. So this is a diagonal. Remember, the diagonals are cut in half. So from L to Q, it says it's 9. So that means from Q to N would also be 9. So the length of the entire thing would be 18. So remember, in a parallelogram, the diagonals are cut in half. It's bisected. Number 7, find the measure of angle MLN. And again, if you need to trace that out to know what angle you're talking about, trace it out. It goes in that order, and the letter in the middle is what you're looking for. So we're looking for L right here, MLN. Now, because we have parallel lines, okay, these are parallel to each other. If I extend these out to make parallel lines, that means I have alternate exterior angles, I have alternate interior angles, I have corresponding angles, I have same side interior angles. All those angles we learned a few months ago is present when you have parallel lines. So to find this angle right here, if you notice, I can make a Z on this parallelogram. Doesn't matter which way it goes, I can make a Z. A Z means you have alternate interior angles which are congruent. So if I look at this line right here, the angle that's on the opposite side of this line would be 32. Well, that means this angle would also be 32. These would be alternate interior angles. They're on the inside of your parallel lines. You can form that Z around them, and they're on alternate sides of this diagonal. So that means they're equal, so that means angle MLN would also be 32 degrees. And the last one, the length of QN, we already found that to be 9 because the diagonal is bisected, it's cut in half. So there's page 11 worked out. So again, if you need to like pause it, write